Hello, this is Dr. Flight, and we're walking through some analyses for MANOVA. And specifically, what we want to do is investigate what we call a K factor MANOVA. So when we do a K factor MANOVA, what we mean by this is that we have an independent variable that has more than two levels. So a kind of a single factor MANOVA might be one where we can have more than two or one or two or three or more dependent variables. So those would be the metric variables. But what I'm talking about here is on the other side when we have our grouping variable. And if we have more than two levels, we may have three levels or four levels or more. And then that would be what we call a K level or K factor. K is only a term that's used for an unknown number. So it could be any number. So it could be a 3 factor or a more than 2 factor is what we're talking about. So K group design simply means that we have more than 2, and K is that number of groups within the individual factor. So in this example, we have 3 dependent variables: likelihood to recommend, likelihood to purchase, and satisfaction. But then within the factors, within the independent variable, in this case it's going to be this customer type X1, it looks like we have 3 different groups of customer based on how long they've been our customer. And so instead of 2 groups, we have 3 groups going on here. So that would be what the K portion, the K would mean 3 in this particular case. So this is a 3 factor or 3 group type of a challenge here. Again, 3 dependent variables are present here, and then we have 1 independent variable, and that independent variable has 3 different levels associated with it. Note here that less than 5-year customer average is the highest in all 3 independent variables, while 1 year is the lowest. So we have a 7.8 versus a 5.7, 7.5, 6.1, 8.1 versus a 6.9. Now, just eyeballing this, you can see that there's a fairly good gap between less than 1 year and over 5-year respondents for each of these variables. One of the questions will be whether the inside relationship going on between 1 and 5 and over 5 is significantly different. And even perhaps we look at the difference here, or here rather, we might look at the difference between those two. So the first and the last groups are almost always significant from each other. One of the things that we often want to test is the intergroups, in middle groups, and see whether there's significant difference between those groups as well. And that's something that we'll look at here as we move forward. So again, with this type of work, we need to double check and confirm our assumptions. So when we're running this analysis for MANOVA, we're going to do general linear models, and then we're going to run multivariate. And we'll do the tests that we would normally do. So Bartlett's test for correlations and the R for correlations. We're going to do normality. We'll do outliers. We'll do heteroscedasticity testing to confirm that the groups are similar in terms of how much variability they have on the dependent variables across all 3 groups. Now you'll notice with this, we run the multivariate analysis, we check other options, which would include homogeneity tests, and we're going to look at the boxes test, and we're going to look at the Levene's test. So the box test is above 0.05, so that is what we want to see. However, we're going to look at some challenging issues here that may be problematic in terms of the Levene's test, and in specific detail, the satisfaction variable. It would appear, because satisfaction is not above 0.05, in significance here, that this may be a challenge. Generally, though, if you have a large enough sample between respondents or among groups in each group, um, and um, and you don't have systemic challenges across all the other variables, then we're going to be able to probably ignore this as being problematic for one specific variable at a time. We're going to move forward with the analysis at any rate, and we may use that as a limitation later on. Again, double checking the assumptions. I don't again have on this linearity, but we can do a scatter plot for each of the relationships among the three dependent variables, and we can eyeball this and we can see whether linearity is confirmed. We can also look again the R in just a correlation matrix would be good to do. We could also confirm that with the Bartlett's test, and then also test for normality, which we would typically run through explore and descriptives, and look for outliers. So again, those are your regular types of data assumptions that we're going to look at oftentimes with multivariate analysis anyways. You've probably done a lot of this already, just getting to know the data, but with the HBAT data, you can run this through the textbook. You can use this data as a practice tool for this analysis. So next, we're going to actually run the analysis. And as we're doing this, again, I'll pull this up. Remember, we're going to do analysis, general linear model, and then multivariate. And again, what we're looking for are the multivariate tests specifically that were run, and then we're going to look at the univariate tests as well. So the multivariate tests that we run, so the Pillais, Wilks, Hotellings, and Roy's test is what we look at. And those all, as a collective group, indicate that there is significant difference between the variates for each of the three groupings that we have, and specifically that we have some significance across each of the variables as well. There is going to be another layer of testing that we do. As we look at this, though, it'll include a post hoc test, just like we would look at when we look at an ANOVA, to confirm that there's significant difference between groups on each of these variables individually. So that's something that we'll actually do sort of next in line here. So univariate tests indicate that we have significant power or ample power as this is close to 1, and that we have noting earlier, we looked at the differences in means here, and what we would suggest is that as a collective group, there appear to be differences, kind of like as the F-test and an ANOVA, in that there is significant difference between groups in some capacity. What we can also do, though, is, as I mentioned, a post hoc test within the same analysis, just to confirm that that's going on. So the Sheffe or Tukey or Bonferroni tests, multiple post hoc tests are available. But it'll come up just kind of like you'd expect to see in an ANOVA, and we'll look and we'll see between for each variable, so under satisfaction, for instance, less than 1 year, 1 year to 5, and then over 5, we're looking at like the individual tests that you can run to confirm that these are different. And what we're going to have is, again, we've got significance with satisfaction, we have significant difference between groups with likelihood to recommend, except when we get to the 1 year to 5 year. So we have that middle group, the 1 to 5 year, and then the 5 year, and we look at the mean difference. And we asked earlier whether these would be different or not, and it would appear as though it's not significantly different for likelihood to recommend, and then also likelihood to purchase as well. It's not different, not significantly different. If 0.05 is our cutoff, then we would say the same thing. So one of the things we questioned, we knew or we thought that the extreme groups, less than 1 year and over 5 years, would be significantly different. The question that we asked earlier was, well, once we add that middle group, will there be difference between the middle groups, and kind of just eyeballing the means between the middle group and the high group, in this case 1 to 5 years to over 5 years. So for two of the variables that was not true. For one of the variables for satisfaction it was. So that is just, if we're gonna do this analysis, we might even just group 1 to 5 years and 5 years together as one group, and then compare those to the ones who've been with us for less than a year. So that's kind of the interpretation of that. And again, when you have more than 2 groups, you need to run the post hoc test to confirm where any significant differences may lie, if there are any at all. If you don't have more than 2 groups, then you don't have to do that, because the ANOVA, or the test that's being run, is already between 2 groups. Your overall test, if it's said to be significant, then tests between the 2 groups that are available. In a K factor analysis, the overall tests, while they might be significant, the multivariate tests, while they might be significant, it doesn't necessarily mean that all the relationships within the factors, the K number of factors, are. So that's what we found here, that there's actually the overall variates differ between groups, but the individual variables within each variate don't necessarily, for likelihood to recommend and likelihood to purchase, because of those. Okay, so yeah, that's the analysis. That's just kind of running it. There's a whole bunch of interpretation that needs to be done still, but this is the analysis that it yields. If you have any questions, let me know. Thanks.